I do it again. I have to unmute myself. Good day, good morning, good afternoon, good evening. My name is Ivo Avinga. I'm from the statistics division, and I will be your chair for this webinar on the interactive and digitally enabled statistical standard and classifications. I welcome you all. This is, I would say, a rather new topic, at least at the global level, to start discussing the digitalization of standards going forward, using the techniques that is already well known to most of us.
Ivo, you're muted.
I do unmute myself, but apparently you can't hear me, and I hear also that the webcast is on. So maybe I have to try to turn the webcast off.
We can hear you now, Ivo. Loud and
You
clear.
can hear me?
Ivo, we can hear you now. I just unmuted you. Yeah.
You have to. Okay, you have to do that. Okay, good. All right, that explains. All right, we start again. Sorry for this glitch. I start just from the beginning. My name is Ivo Havinga. I'm from the statistics division, and I have the pleasure to chair this webinar on interactive digitally enabled statistical standards and classification. It is a rather long title for a very interesting topic, in being able to discuss at the global level the digitization of our standards and classifications. It's a new sort of development, at least for the statistics division at the global level. But we are very happy to know, and you will learn today, that quite some work has been done in this environment to actually apply this web-enabled technique to be able to link conceptual developments of statistics across our standards and classification, and then also link them to other documents. We are very familiar to this technique, actually, when we do our searches on the web, because that's all enabled with the similar sort of techniques, but we never really applied them in our own sort of standards. And it will really allow us to work in a different way and communicate differently using these type of techniques, when we are able to enable our standards and classifications with these techniques. So today you will learn from 3 segments how these techniques have been applied. We will start with a segment of the digitization of classification, which is led by Andrew Hancock and Franklin Usumo from Statistics Canada. So New Zealand and Canada have applied this, and we will learn from them how they have applied these techniques. We will also learn from a segment that is led by Katrina Carusillo and Carola Fabi from the Food and Agricultural Organization, who will also show how they have applied it in an agricultural classification called Caliber. And then finally, we have a segment from my UN colleagues that I will introduce later on, that have applied it for the SDG ontology, but also it is very much used at the UN library in terms of the use of these techniques to actually be able to make the papers in the library very digitally searchable. So we will see these 3 techniques in a very nice way, how they can be applied and how we want to move this forward in applying that to our international standards. Now, in terms of the organization of this webinar, as I already indicated, there are three different presentations in 3 segments. We will organize them in rounds of about 40 minutes, about 30 minutes presentation, and then we would like to open it up for question and answers for about 10 minutes. So in total, we would have about 2 hours of the 3 presentations. But I think they will all be very enjoyable and entertainable. And I hope that we will have a communication with the audience. And we have quite some participants and expected more to join. So we look forward also to a dialogue with the presenters on these different sort of topics. Now, with that, I would like to turn to Andrew and Franklin. Andrew is from Statistics New Zealand and Franklin from Statistics Canada to start their presentation. Andrew, the floor is yours.
Cool. Thank you, Ivo, for that introduction. I hope everyone can hear me. As part of our start of the session, I'm going to talk and just do a short PowerPoint presentation which looks at the rationale and purpose for why we want to change the methodology around statistical classifications and standards and move to new technologies and metadata modeling processes. And then we'll hand over to Franklin and Stefan at Stats Canada to have a bit of a conversation around that and what Stats Canada are doing. And then hopefully we'll be able to just give a short demonstration at the end of the Stats New Zealand, Stats Canada ARIA system, just an overview from our website. So I shall endeavour to share content. Okay, so welcome everyone. The system of economic statistics contains overlaps in concepts and definitions, classifications, and metadata, which means information is not easily nor readily integrated across the various standards and frameworks that exist. For example, the system of national accounts or the balance of payments manual will contain similar but not always identical content, and each is refreshed and updated in isolation of the other. This hampers responsiveness to emerging user demands and the ability to incorporate real-world change. Serviceability of the various economic manuals does not easily enable easy cross-reference of content, and search and discovery of content can be challenging for expert and non-expert users alike. For national statistical officers, there is significant time and resource required to develop, revise, and maintain this content, with most of the process designed for human understanding and not for system or machine exchange. And this poses difficulties in implementation and use across IT systems and platforms. The purpose of this work is to advance the use of innovative technologies and approaches, cross-referencing and navigating between the various economic statistical standards, manuals, and classifications, and ultimately across the wider international family of statistical classifications. Data is now collected from sources that did not exist 10, 20 years ago, even 5 years ago, and there's greater volume and variety in that data for which these massive economic manuals and frameworks are not keeping pace. It is time to explore the wider use of relational databases, computer-created matrix software, and semantic web technologies for managing and describing data and improving the way the economic standards are developed, maintained, and implemented. Advances in ontological engineering allows digital integration with well-established library and other vocabularies, taxonomies, to improve cross-disciplinary search capabilities of digitized documents. And some of this will be covered later with the UNSD presentation, I believe. The traditional approaches that we have with our frameworks and classifications hide the conceptual relationships and create structural silos and do not easily address cross-cutting issues. And as we move more and more into the revision cycle of some of our major classifications, this cross-cutting nature is becoming more and more evident, and our traditional approaches to developing and maintaining classifications using traditional approaches of parent-child relationships and hierarchic structures is no longer meeting the needs. We can no longer be as responsive and fast and dynamic in addressing user concerns. So we're looking at a concept-based classification model. Concepts are the building blocks for everything. Without them, none of our statistics, none of our data has actually any meaning if we can't agree on what the concept is we're measuring and how it is described. So a concept-based approach is being trialled in New Zealand and Canada, which will add value to data by increasing the content and metadata that can be created. The intention is to enable greater integration of administrative and statistical concepts and introduce semantic consistency across the standards. The model is intended to encourage greater reuse of existing content by storing once and sharing across multiple locations with a view to removing the cyclical, labour-intensive, time and resource revision process that we currently have. It begins with a clearly defined concept, which may have relationships to any number of other concepts or sub-concepts, which allows for conceptual frameworks to be created. Each concept is unique and forms a scope for all the entities or words that may be categorized by that concept. Concept has a label and an agreed definition. This results in a category set, which is a bit like an SDMX code list, which can then be cut and diced to reflect user needs. So the idea is that we have an agreed concept with an approved definition. There may be contextual iterations of that concept enabled to help greater usage, but the category set idea is basically a list of all the words that are within scope of the definition, and that category set can be dynamically updated and added to by approved users and through a lifecycle and audience model control process. That allows regular updating, the addition of new content, and then it is up to users to decide when they wish to take that new content and add it into their data sets or their data collections. Critical aspect is to get everyone talking about the same concept, category, and content in the same way. And at the moment, there is an element of inconsistency between the different manuals and standards that exist. For example, what do we mean by the concept of industry? There is an SNA definition, and we have an international standard classification of industry. But the concept of industry isn't defined in the classification itself in ISIC, because that refers to all economic activities. But everyone refers to ISIC as the industry classification and talks about it in terms of industry. But the SNA definition of industry and what ISIC covers are similar but different. And that's one of the problems we're facing, trying to get that consistency in terminology and consistency in application. Traditional approaches lead to hierarchic structures with parent-child relationships, which limit the storytelling with the data. A matrix-style approach introduces a familial approach, so it can bring in other attributes, entities, and relationships and concepts to bring more richness to the storytelling by having those related concepts and content. The creation of the linkages between the concepts allows us to take a piece of data and transition it through different concepts and different classifications, which currently is hampered by standalone classifications having to be mapped to each other using concordances, a lot of manipulation of data, and it's very hard to see how those relationships actually work. The focus moves to user-defined content and removes the pressure on national statistical officers to take the lead in the revision process. We can hand over to subject matter agencies or key stakeholders the primary control of the content. After all, statistical officers can't be experts in every single variable or topic. And that's one of our challenges when we come to building classifications and frameworks. We're expected to understand all the concepts. We're expected to understand all the contexts those concepts are used in, and we're expected to understand the relationships between the different variables. That's not always the case. This approach will help introduce flexibility, and that allows greater contextualization to suit user needs and provides a more dynamic and responsive approach to content. In addition, search and discovery, retrieval and interoperability are enhanced through greater use of APIs and accessing linked entities and content within the network of the system. So we take an example which sort of highlights the challenges of traditional approaches, and that to address new content or change something takes time and resource. Otherwise, you're forced to shoehorn content into existing categories or frameworks and not necessarily reflecting the current world. So if we take ISIC, the International Standard Industrial Classification, and the concept of manufacturing, we have a definition which basically defines manufacturing as a transformation process based on a concept of manufacturing, which is based on things like building a factory, employing staff, investing in tools and infrastructure, obtaining and sourcing raw goods, and transforming goods into a product. The outcome is the classification classifies all those activities of manufacturing, the types of processes used for manufacturing, or by the products produced. But what if we have this concept of factoryless production come along? Where do we fit this into the ISIC classification? How do we fit it in? What does it actually mean? Is it manufacturing? Is it something else? Basically, we would say factoryless production is based on identifying services and intellectual property ownership. So therefore, is it a transformation of materials? Does it require new products and plants or factories? Does it use power-driven machines and equipment? Possibly, possibly not. But faced with this concept, we have to try and work out where in ISIC we need to classify it. And at the moment, we're forced to try and fit this into something that classifies by type of process or product produced. And it becomes increasingly difficult to identify core business activities, primary activities, and accurately classify because the classification doesn't reflect the real world. And so we want to move away from this type of approach. The challenges with the traditional approach are that we have to try and use the existing content and structure, and then make a decision around should we add definitional guidance text somewhere in the manual or in the classification? Is the concept actually manufacturing, or is it something that sits within services, or is it wholesale retail, or whatever? It's not easy to address real world change at the moment. So the new methodologies we've been exploring require better usage of service-orientated architecture, look to uptake simple knowledge organization systems, SCOS and XCOS, integrate with the known metadata standards such as SDMX or ISO 11179 or DDI, whatever, and provide greater usage of taxonomies, thesauri, ontological engineering, and concept management to mix structured and semi-structured data together. It's encouraging multiple output views, different labeling options, and multilingual content linked to an approved concept. So it's really taking a quantum step forward in how we manage and develop classifications and standards, and getting away from traditional hierarchies, which are very much constrained by the notion that we are producing a book with an A4 page and all the constraints that go with the width of an A4 page, and then trying to turn that into something that can be put into an IT system. And usually we produce the book, we turn it into a PDF, and then we expect users to come along, take that PDF and do something with it. How do you take that and easily integrate it into a processing system, a survey processing system, an output system? Very difficult. So we're looking at new ways of taking that same information, digitizing it, and making it much easier to define and classify and disseminate. But the critical thing is this is a transitional approach. We're not coming along saying, let's get rid of the current approach and turn it around into something completely new. The transition will enable us to continue our traditional classification look and feel whilst introducing new customized views of concepts. Users need time to assimilate and understand these new ways of defining, classifying, and disseminating statistics, and particularly economic statistics. So in using SCOS, the advantages of that, obviously, are that concepts can have multiple relationships. And it's like a neural network model. We often talk about the approach being like a bowl of pasta with a sauce on top. The user sees the sauce, and underneath we're trying to put all the pieces of spaghetti together in this great network to inform and provide a rich story of the data. SCOS allows us to use unique resource indicators, or URIs, to link with lexical strings, to assign notations and links to other concepts, so that this integration and this unique identifier gives us greater flexibility and greater ability to get into more micro detail. We can continue to organize content into informal hierarchies and networks using defined concept schemes. The URIs remove the constraint of having a single descriptor or mutually exclusive labels. We can put in multiple ways of describing things, which gives us a lot more flexibility for output purposes. We can use synonyms or aliases for categories, and it provides more granular metadata and easier integration and sharing of concepts and content. Supporting that is the use of the resource description framework with RDFs. Again, we've got unique web identifiers for describing resources or entities. We can use the RDF triple, which comprises a subject, which is a web resource, a predicate, a property, and an object value. This allows us to take classification content and disassemble it into its component parts of codes and descriptors and definitions for easier integration and sharing. And then we can reconfigure it or repackage it back into that traditional content, or reconfigure it or repackage it into other defined views. And the other advantage is that we have access to use graph networks or query languages such as Sparkle to retrieve and manipulate data. So it gives us a lot more capability in managing the content and metadata of our classifications. So a rough example of an RDF triple, and there's a much better example in the UN presentation later on. This is a very simple one, just to take ISIC again and the example of aquaculture. Aquaculture as a subject is an industrial activity, and it can have many types. So RDF enables us to break it down to these component parts. So when we look at ISIC, we have agriculture, forestry, and fishing, which is a type of industrial activity. We have aquaculture, which is a subclass of agriculture, forestry, and fishing, but is also a type of industrial activity. And then with aquaculture itself, we can create further subclasses of freshwater and marine, for example, and then within those subclasses create more memberships or categories under that. And these can be much more easily updated and changed and modified without the whole need to go through a massive cyclical revision process of classification. All of these can be concepts in their own right. For example, salmon can be a concept, lobster could be a concept, freshwater could be a concept. But it's creating those linkages and describing things in ways that we currently are not able to do with our traditional approaches. Another example might be to take something like country. And this example is primarily based around the use of Australia, and the categories presented are just a subset for illustrative purposes. So the fundamental approach we're taking is of chunking down the content and reassembling it. So we start with our concept of country. You can see it has an agreed definition which forms the scope. The concept of country itself has a relationship to other concepts such as birthplace, citizenship, continents, location, nationality, regions. Within that concept of country and that definition, we have a category set which lists all the countries in the world. They themselves can be concepts in their own right, which would then allow us, for example, to take Australia as a concept, link it to location, and the category set could then be the states and territories of Australia. The ability of this is that we have the code separated from the descriptors, so that instead of having multiple versions or multiple classifications with different code patterns, the codes are stored in a code bank. These are user defined and approved. The examples we have here are the ISO 2-character alpha, 3-character alpha, the ISO 3 numeric and 4 numeric code is the Statistics New Zealand code for its hierarchic classification. And examples we're showing are just the codes for Australia. So the codes can be, as I said, user defined, and users can pick and choose which code they want to go with that category, so that we don't have to predetermine and prescribe a classification with code patterns. And out of that linkage between the concept and the category set and the code bank, we can then start to create views. We can create a hierarchic view by bringing in another category set of labels, which gives us our continents by linking to the continents concept. We can recreate ISO 3 numeric or ISO 2 alpha, or we can create any other number of views. All the content is time-stamped, and each entity has an unique URI. APIs are in place to enable integration of systems and to link content. It uses a customizable lifecycle and approval process. And content can be disseminated in multiple formats, such as Word, Excel, SDMX, DDI, or PDF. And the content is also stored and can be disseminated in multilingual formats. We take another example of industry, similar sort of thing, concept of industry with definition. We can introduce different types of related concepts. On the left-hand side of related concepts, we have agriculture, construction, energy, manufacturing, etc. These can be used to form the top level of the classification. On the right, we have related concepts of the CPI or GDP, households, non-profit, SNA, unpaid work. And having that set of related concepts then starts to enable us to link the category set to those related concepts to produce views of GDP by industry or CPI by industry. The category set, again, is just an illustrative example of the types of things that would be within scope. Again, we have a customized code bank, so users can predetermine can pick and choose which codes they want to apply. And out of that, we can produce any number of views. We can produce an ISIC view, we can produce an AIX view, we can even produce a cross-cutting view of tourism, anything like that. So it gives us a lot of power and a lot of capability going forward. So I'll finish this part of the presentation by saying that it will take time to fully move to a new metadata modeling methodology. And the benefits are not just for the national statistical offices, but the national data systems, because you can introduce a single source of truth. That can be more user-driven content. There can be greater stakeholder engagement and more dynamic reaction to real-world change. The ultimate benefits are cost reduction, better resource utilization, and greater responsiveness. Stats agencies don't have to invest so much time using this methodology to build classifications and frameworks, because we can divest some of that work to the user community and have it user-driven much more dynamically. It will make ultimately the economic standards more integrated, consistent, relevant, and easier to use, because we will start to be able to link the concepts across, the classifications across. So, for example, the SNA holds functional classifications. They may be replicated in another place, but they may not be identical. And it's that risks of things not being identical that introduces inconsistencies. They may look the same, but there's just a little difference. So therefore, are you talking about the same thing? It's not quite like the situation of comparing apples with oranges. You may still be comparing apples with apples, but you may be describing Granny Smiths with Red Delicious. And whilst they're both apples, they are different. So it's just trying to enable those sort of subtle, nuanced differences to be encapsulated and used. We believe the use of semantic web and metadata modeling is the most practical way forward for improving the way we manage and develop our classifications and standards and how we make them more dynamic. And ultimately, our longer term goal is to make better use of AI and machine learning to reduce human intervention in the future, because much of the content development can be automated. So I'll stop there and hand over to Franklin, if that's all right, unless there's any questions.
Franklin, can I pass on the floor to you? And if Franklin, yes.
Hi, this is Stefan Knight. I'm assisting Franklin today, so I think the next step is really to see if there's any questions from the audience.
Okay, Stefan, thank you. Thank you for taking it over for Franklin. Welcome. This is Stefan Krieg. He's a colleague from Franklin. So the question is, are there any questions at this point? I don't think so, Stefan. I think you can proceed.
Okay, so
Well, sorry, there are some comments in the chat, Ivo.
I think there's a question from Sanjeev. Hi, Sanjeev, how are you doing? Sanjeev is from the UK ONS. To Andrew, this is very useful already and helpful, particularly the granularity of the links to use to reduce the labor intensity of our work. Can you say more on the top-down classification versus bottom-up classification?
That is a very good question. That approach is still something that can be done, because we can start to look at how the different units are structured and how they're linked to each other. The top-down, bottom-up approach has still got merit, but it's more around that process being around creating hierarchies, and the hierarchies introduce inflexibility, and hence the idea of moving to more granularity in the links and automating, particularly in the idea of automating the correspondences, will save time. In terms of the economic units model, I would need to have a bit more of a think about that before fully responding to that, and I might take that away and just have a bit more of a think and provide a comment after the side event, if that's all right.
Thank you. Thank you. There are no more observations that need to be answered at this point, Andrew. Stefan, would you like to?
Sorry, Ivo. I think there's a question also from Indonesia in the chat.
Benson, can you read that out, please?
Sure. There's a question from Heidi of Statistics Indonesia. He's saying that some countries have modified version of concepts and classifications due to their country's specific circumstances. How do we deal with this?
That can be managed through the audience model, and different groups can be given authority over particular parts of the content. You have customized views. So a good example would be with ISIC. If we would say Australia and New Zealand has a view of ISIC, which we call ANZIC, we can have that in the system. We can link it across to the international standard, and through the API process, the intention is to have a two-way process whereby not only can you use an API to take content out of our system and use it, but also for us to suck information in from other places. So it reduces the overheads of monitoring change. And an explicit example I will use in the New Zealand context at the moment is a plan to integrate our standard occupation classification with the United States ONET system. ONET is a massive system which clearly has more content than the New Zealand labour market will ever need. But the competencies and skills information in there is something we're very keen to assimilate. So at the moment, we are setting up a correspondence between our classification and the United States one to get a linkage, and then we will use that linkage to start pulling the ONET information back into our ARIA system and into our occupation classification. And so whenever ONET's updated, we'll have an automatic update into ARIA, and the changes in the different contexts from the Australian New Zealand perspective will be added in, and then we can flow that back across and link it to ONET. So it's very much around enabling distinct views of information and content, but it is linked to an agreed concept. You must start with the agreed concept. So if you agree that the definition of country is the definition you want to use, then you use that category set and you use the content and you cut and dice it for your purposes and create your own view. If you want to add stuff that is not in that category set, or if you believe the concept is different, the plan is that you as a user propose that content for change and it gets included as an option. But it's very much around enabling context and even country-specific circumstances to be better handled and linked to a master set or a master standard. I hope that answered.
Thank you, Andrew. I would like now to move on to Stefan Kriet or Franklin, and as has been indicating, and I think that came from Nicola. Of course, some of this information is new to most, but bear with us. Progressively, you will get demonstrations to actually show it beyond the conceptual slides, to be able to get more sort of tangible sort of visualizations to understand the concept as we develop them. Stefan and Franklin, can I turn to you?
Yes, can you hear me?
Yes.
Oh, okay, that's good. I've been having some issues with my audio, so I switched to a separate device where I'm talking and you see me, it's another one. So hopefully it works fine. Again, we'll try to kind of show a little bit of what StatScan is doing around, digitizing the way we process or manage our classification and standards. I have to say that in a sense we are at the beginning of at this journey. In general, like what Andrew just presented, it's something that we kind of agree to pursue. we're not necessarily there yet in terms of, establishing all of these systems of managing, but we definitely focus on these, new ways of doing things. We definitely engage in helping, ourselves do better in terms of managing classification and standards. So I will before we get into a little bit of more on the area how we've been, starting to use it. I will just have my colleague Stefan just entertain you a little bit in terms of whether we're doing enough with using some of those data standards around the way, again, we're trying to integrate our system and better share also our content. Stefan?
Yes, thank you, Franklin. So to describe maybe a bit of the sort of our context within Statistics Canada, we feel that classification, statistical classification is really the foundational piece to help us better manage the metadata. We just recently have pivoted to a model that will make a lot more use in terms of the data standards. As you know, statistical organization needs to make use of both SDMX and also DBI. These are sort of two foundational data standards to really help us better manage and disseminate our data within the organization and to our users. So the classifications themselves, I mean, we're spending a lot of time to really have the ability to interoperate the content with SDMX and DDI for our users. So this is great. It's great for many reasons. I mean, giving us a authoritative source to manage this type of data. It is so useful to our users to have this embedded within SDMX DDI. Traditionally, what we would do is we would make copies of our statistical classifications to feed our data standards like SDMX and DDI, creating additional steps within the process themselves. Where we want to move even further is to be able to feed other types of capabilities, either being search and discovery.
Stefan, I see in the chat. Can you speak up a little bit? You're a bit soft in the voice. Yeah, you have to strain a bit. So if you loud a bit louder, then we don't have to strain too much.
How about that now? Can you? Is it better?
Much better, thank you.
Okay. So moving forward, we want to make sure that we have classifications really feed our other types of capabilities that are really in line with classifications. As an example, search and discovery. I mean, when we're trying to allow sort of a rich search functionality for a user, this type of metadata is extremely important. So the fact that we are moving towards a semantic approach will give our users better ways to be able to search our data. Given the ability to tag related terms and synonyms and even inclusions, exclusions, and as well, I mean, other types of capabilities that will benefit from this approach is definitely the classification, the coding and classifying of the data itself. We rely a lot on metadata, so statistical classification, and we feel that by moving to ARIA and having a much better way to manage, I would say, the content of the classification will allow us to do a much better job within, let's say, the classification of our data, and giving us the ability to also benefit from AI and ML as we move forward because of this strong semantic approach. So just to maybe wrap up, I mean, as I was saying, I mean, the data standards is really key elements within our metadata ecosystem. So for us, it's really trying to identify what is the best way to link the data standards such as and metadata standards such as SDMX and DBI with ARIA, the classification, as we see classifications being sort of the foundational metadata piece that will enable us to link everything together.
Thank you, Stefan, for explaining the use as you see them in terms of metadata management, also better to serve your users in terms of access to the metadata, disseminating data, but also the metadata related, and find them and easy for discovery. Franklin or Andrew, is there also an option of demonstrating ARIA, or are we basically moving on to the next? I just wanted to double check before I move on otherwise.
We can attempt to give a simplistic overview of ARIA, if you like, Ivo. The challenge for us is because we're having to run the content from our personal laptops and not our work devices. We don't have full administrator access to give a full demonstration. So I could give a very quick overview of ARIA from the StatsNZ website, if that would be useful. Otherwise, I'm happy to do a session for anyone independently of this meeting, for anyone that's keen to get more understanding of what we've been doing. I mean, ARIA has been 10 years in the thinking and progress, so it's been developed from a global perspective, using all the knowledge we've gained over the last however many years on classifications and standards, with a view to Stats New Zealand being effectively the first cab off the rank to use the methodology and the vision. It's not a Stats New Zealand idea which we're producing a tool which we're trying to sell. It's about a vision and philosophy of doing things faster, more efficiently, more user orientated, and just getting rid of those traditional approaches which provide the constraints for us in our metadata and our classifications and standards. The cyclical review processes, the implementation issues, we've put a lot of effort. So I can, if you want, give you a quick run through what we've got with ARIA at the moment. But as I say, it's a sort of limited view, if that's what we'd like, Ivo.
Yeah, maybe what we could do is that we give them an opportunity later on to have a special session on ARIA. I think that would be better to to get a more sort of broader view. Meanwhile, then we can move on to the other presentation, because we're over the 40 minutes, right?
Yes, I would agree.
Yeah, thank you. I just want to open it up. Are there any particular questions at this stage before we move on to our FAO colleagues to present Calibre? If not, then we move to Caterina Caricello and Carola Fabi. They're our colleagues from FAO that have developed also a tool. It's called Calibre, and that demonstrates the use of this semantic web technology on classifications related to agricultural statistics, which is also available on the FAO website. With that, I turn to Caterina and Carola to make their presentation. Welcome.
Yes, thank you, Ivo. Good morning, good afternoon, good evening, everyone. So my name is Carola Fabi. I'm a senior statistician in FAO Statistics Division. I will open up the presentation and just give the initial overview and then hand over the floor to Caterina Caricello to introduce the Calibre. This is really to give, Caterina, if you want, you can move to the first slide. It's really to give you the entry point to the Calibre. So this work that FAO has done, developing an open link classification platform, but coming from a completely different entry point from a national statistics office, because we are an international organization. We are custodians of 21 indicators under the SDG with an international mandate for data collection, dissemination, and setting standards on food, agriculture, fishery, forestry statistics, and with a drive for innovation, especially with the new technologies that have become available recently. FAO has, so why did we step into that? In fact, there was an internal push and an external drive. So the internal push is that the organization has a decentralized statistical systems with many units using either different or the same classifications, and the need to link, an increasing need to link and integrate the databases and the data sets. We are consumers of 12 international classifications, but in some cases we adjust because we have a sectoral interest, so we have to go deeper down than the international classification, and we have a stake in developing the international classifications, either as so we contribute to develop a few of them, and we are custodian of a couple of international classifications. And internally, there has been an increasing effort to harmonize and integrate the reference lists to avoid having different units duplicating the international classification reference lists for their own data sets at the risk of some inconsistencies, and anyway, making interoperability and data exchange difficult. So this was the internal drive, and in fact, we have a master data management system for a few years. The external drive is that we request data to the countries, and we want countries to provide us the data in the international classifications that we use. And at the same time, we receive data that is not standardized and that reflects the national classifications or varieties in a number of cases. So this for us was a kind of a stress test also for the system that we have developed, where we have developed a model to be able to manage the adaptation of the international classifications. For example, of the CPC, the Central Product Classification, FAO uses the 2.1 expansion for food and agriculture because we need to go deeper down. And so we had to develop a data model to manage this expansion of the international classification, its correspondences to the various versions of the CPC and to other connected classification, especially the HS for trade data. And also on the external drive, we have a request from our partners for data transparency and traceability. So here you can move to the next. And so the starting point was really this call for transparency and traceability and openness, in particular of aid data. Now, there is an international classification for classifying aid and projects, but just to give an example, food security until very recently was not an item in this classification, and you can imagine how food security is important in international aid for an organization like the Food and Agriculture Organization. So, in fact, this push led to an international initiative on transparency of aid data, combined with the need to re-examine the classification and standards used for the reporting activities. So, basically one of our main international partners, the Gates Foundation, combined the two aspects in a project. And that helped us developing the caliper. So with the objective to provide an interoperability tool, an open link data format for reporting aid activities, but also for exchanging data between FAO and the countries, and for countries to adopt the international classification, especially on food and agriculture. Of course, the caliper, so the platform that we've developed, went and goes much more beyond the topic that led to its development. It currently hosts 12 classification, and it has attracted a lot of attention outside the statistics division in the FAO. We have tested the interoperability, for example, with the FAO statistical working system that was developed starting in 2001, so on an older technology. And actually, the interoperability with Caliper works very well, in some aspects even better than with a master data management system, especially when it comes to using a single metadata model. So we have, whereas the master data management system requires, for example, tailored harvesters to import every single reference list, whereas with a caliper there is a unique, or actually there is a limited number of metadata models, and so just one API suffices. This is really to give the broad framework of what led to the development of Caliper. So I leave the floor to Caterina so that she can present you the platform and all its various features. Caterina.
Thank you, Carola. Hello, everybody. Greetings from Rome. Ivo, if you can confirm that my volume is set right, you can.
Perfectly. Thank you, Caterina. Go ahead.
Okay. So the presentation for today will be, it's organized into two parts and not too long. Don't worry. The first part is about an overview of Caliper to explain a little bit the why more in technical, from a technical point of view. And then we'll have a selection of three main features. And then in the second part, a little bit more detail on the modeling paradigm and the tools and the applications. And of course, some comment on ongoing and future work. So what it is, Caliper is, let me get rid of this. Okay. So Caliper is a web platform. So in practice, it's a website where you can go and get statistical classification. In this sense, it serves classifications in formats that are machine readable and actionable, I would say. So in formats that can be used by computer applications of different sorts. It is based on open standards, and it supports all steps in the data life cycle. And that means creation/maintenance, so editing and creating new classifications, and of course, publication and use. So if you go, this is to give you an idea, this is a menu from the website. Edit, that refers to creation and maintenance. Part on publication that is mostly like thought for human users, so search and browse. It's basis. You can also download in different formats and have functionalities for machines. Also download, you eventually use it in some computer applications. So you have URIs, APIs, more on this later. So right now we are in a transition of moving from the website that was specific from the project to an FAO space currently under review. So it's in this transition we have the two websites alive at the same time. We won't have a demo for Caliper today, but I really warmly encourage you to go to the website and test it, and please come back to us with comment, questions, or criticism. Very happy about it. So why Caliper? As Carola mentioned, a grant from the Bill and Melinda Gates Foundation to support IATI. It was a large grant, and there was a specific smaller component on producing interoperable, better, more interoperable data out of the reports made by donors. So with IATI people, like institutions having something to do with aid flow, with aid to countries, they report their activities. And that was the area in IATI where this project was focusing. And so Caliper in the end originated from one observation made while working on this project. And the observation refers to what happened during a workshop. We had a workshop in London with the technical IATI technical team where somebody was explaining the post-processing of the data, some cleanup that had to be done on the data from the IATI reports, because there were a few problems. And what happened was that some reporters got confused and used the wrong codes to identify the geographical areas where they were working, where activities was taking place. Why this weird error happened? The reason is that given the way the system was organized, people, well, they had to use codes in isolation without the context of the classifications where the code was coming from. So error was easy to make mistakes. And this is something. So this is an example of ambiguity that we well know from language. In English, it's a well-known ambiguous word. The polysemic word is Turkey. It's a bird and it's a country. But exactly the same applies to codes. Having numbers doesn't really avoid ambiguity, because I picked up this example, 0111 can be wheat in CPC to 0 and to 1, and can also be growing of cereals except rice, blah, blah, and so on and so forth from in Isaac revision 4. No doubts they are close, they are related concepts. The two classifications are related, but they are different things. So we don't want to be, we want to be clear about this. So in short, in isolation, codes are ambiguous exactly like words. So the goal of Caliper was to, okay, let's face it, if a reflection follows from this observation about ambiguity, that we have global standards with classifications. That means we have resources that are developed collectively by international organizations, used widely in the world. So they are global standards. They should be also treated as global resources. So first of all, everybody should be able to refer to them without ambiguity. And their sharing and reusing should happen without loss or corruption of meaning. So I'd like to say that the goal of Caliper ultimately is to serve statistical classifications as public goods, as global resources. Content to date. We have included a number of classifications in code lists. We were in experimental phases. Like the main purpose of this inclusion was to test the technologies behind Caliper. A little bit about this later. With the different classifications that are organized differently, testing purposes. Beyond classifications, we also have included correspondences between classifications, and also links, so correspondences to classifications that are not in Caliper. You might know AgroVoc is a multilingual resource on agriculture and all the area of interest to FAO. DBpedia is the data-oriented version of Wikipedia. And CPA is the European version, so to speak, of the CPC. You find these are all screenshots from the website, so you will find all the information on the website and explanations. So the three fundamental features to highlight in this morning or today. The first feature that Caliper gives assigns global identifiers over the web for the purpose of being able to reference and to avoid ambiguity between codes. It applies standard paradigms for modeling. And the ultimate purpose for this is to have interoperable data, or metadata in this case, interoperable classifications, things that you can pass around with the certainty that your partners will be able to understand and process it, because they are standard and publicly described. And then tools that are open source for a matter of transparency. Okay, now a little bit more into like three of the 3 points. Okay, back to the question of the identification. So 011, we know can be two codes. Which one is which? The answer is to use globally unique identifiers, and I would say also actionable. That means that over the web, they serve data that can be used by machines. And specifically, we will use, that's the technical name, these are called uniform resource identifiers, just strings that you can go with a browser, you can type in a browser and you get something out of it. Something for humans and something for machines. These are fake ones. I mean, you can see, but the idea is that the first part, HTTP, should give you the idea that these are web technologies, so well understood and well developed. Then there is a central part, which is the namespace, meaning the space in which our code is supposed to have a meaning, has a meaning. And then there is a local part that identifies the specific resource. Standard modern paradigm. This is a screenshot from ICC, the crop classifications used for the World Census of Agriculture, just a tiny fragment. And the question here is how to best render this information for a computer. Might sound a trivial question, but it's not, because there is quite a bit of information embodied in this piece of text, in this picture, because you have to specify what all this number, digits, words, and empty spaces and new lines mean for a computer. So, for example, that this is a code that is referred to the other code string one line below, above, and separated with an indentation, which is again in its turn connected to the other thing above. Now, what happens is that, and of course, there are names, artichoke, vegetables, and so on. These are connected. There are several ways, the alternative ways of for doing this in computers. But the answer for us is that the modeling, so the alternative ways that are available, the modeling paradigm should be standard. So they should be publicly described and should be globally endorsed. I refer for easy of the example, I referred only to the code and the labels. So the 201 and artichoke, but as a matter of fact, this applies to everything, to the translations, to correspondences, to metadata, version information, and so on. As part of our answer, Caliber and the whole technology adopted relies to standards developed by W3C, the Worldwide Consortium, and DDI, Data Documentation Initiative, was already mentioned, and I think it's so known in the audience. Tools. The other question, the next question, if you want to do something with the data, not manually, is what software should I use? What tools should I use? Our answer is that tools should be oriented to interoperability. So should be able to produce data that can be used by others and vice versa, and transparency. So in particular, they should be they should support natively this standard modeling paradigm, and should support open formats, open source for the software, and according compatible licenses. So this is, remember, this is also in line with the policy of FAO. FAO has a open access policy. There is a also open source license for Creative Commons license for statistical data. So much for the overview. Now I would like to give you some more detail, a little bit more on a few parts. Let's start with the standard modeling paradigm. Again, this is again the same screenshot from before, a fragment from the crop classifications used in the World Census of Agriculture. I mentioned that there are alternative ways of rendering this information. And to give you a sense for this, let's look at the this way, which is this table is exactly the table in from the screenshot. It's a spreadsheet. And the other one, the back is from CPC. So you might notice quite different ways of rendering the hierarchy. In one case, the hierarchy is implicit in the codes, so there is an understanding that more digits a deeper level in the hierarchy. And in the other case, it's the hierarchies is made explicit by using different columns and subsequent rows. This should convince you that alternative ways are possible and that quite some work will be needed to get the data to pass it around. So you should perhaps eventually call the developer and ask for clarification. We use in the line of working with publicly described standards, we rely on W3C and DDI, as I mentioned. And in particular, two standards that are widely used in Caliper are SCOS, already mentioned also in the previous presentation, and XCOS, which is an extension of SCOS for statistical classification. So we remember SCOS, we remember XCOS, and what this means, what those acronym, what all means is that for every statistical notion in every notion in a statistical classification, so look at your left-hand side, the first column, you have a corresponding property to the right. So in a way, it's like providing a standard way for naming your column in a spreadsheet. It's not exactly the same, but it is the same because it's not a spreadsheet, but it is the same in the sense that these properties are given as are given and approved, and everybody are described, and everybody, if you take the SCOS definition, the document, you will know exactly what it means. Again, this is a screenshot from the website. If you're more curious about more, if you want to know more about the modeling, just go there. There is a documentation section. Just one slide trying to give you a feeling for what it means in practice to talk about codes with URIs that become concepts and they use stardom modeling. Again, the same fragment from ICC. Again, we remember that we are under the umbrella and the paradigm of SCOS. And we look at what we have in the table. So we have these codes. We know these are 3 levels. So the very first thing we do is to, let's take a web identifier, a URI I mentioned. So a unique identifier over the web. This is our object or concept, if you want. We assign the information that we have. In this case, we have a code and we have a label in English. We could have more. And this is already the very basic conversion from a code-only approach to a concept approach. The other crucial step to have a concept in this framework, in this way of treating data, is that the connection, so the relationship between the ID and the title and the code is defined by properties given by a standard body, by an international body. So highlighted in blue SCOS, that is the standard that we have in mind. And those are the properties of, for the title and for code. Imagine this for all other pieces of information, including the relationship between the parents, so a item that is broader than others. And again, to go to the next level. Hierarchical information, terminological information, coding information. We also have correspondences between all these pieces of information, correspondences between different classification systems. We have a language to describe this too. Now, why all this is important? The advantage by applying models that are shared and publicly described is that there is a better reuse of data, easier, smoother, which turns into better interoperability of your data. For software developers, this is also useful because in the end, being the model clear, documented, and in a way unique, like as opposed to multiple, they can develop uniform application, uniform interfaces for application. And this is more interesting for the statisticians. You have tools to achieve better consistencies across your information in your information landscape. Tools. Question about tools. The tools using Caliper are all open source and free of charge. Mostly, they are natively use web-oriented technologies. There is a solid commitment to development. So open source means that they are developed by a community, by a community of developers with some obviously more committed than others, and we have strong commitment on this side, which goes together with a large base of institutional users. And which is also important for us, these are all tools that have been extensively tested in FAO, for example, with AgroVoc, the vocabulary I mentioned a few minutes ago. To give you a sense of the applications of the, as long as we have a classification server, we have a space where people can go and retrieve the classification and sets of codes they need. For example, for inclusion in surveys or in information systems of your information system of choice. There is a strong component of user interface, like convenient user interface for casual user or for user who would need to look up definitions or concordances or codes. So there is we have tools for that, for searching correspondences, specific, fully supporting multilingual site component of classification. Then, since Caliper also supports the editing, the maintenance, and the editing side of classification, this is also a service for custodians and maintainers. And lastly, I would like to mention this an application developed by a collaboration between ARIES, is a tool developed by in the Basque Center for Climate Change, and the UNST, to automatically compute SEA, so System of Economic Environmental Accounts. This system already uses the technology I just described. It uses some of the classifications that we have tested with in Caliper and that are also used in for the SEA. For now, it's let's say it's a test because Caliper was a project. As soon as the technology will become like an official service, will work for real, and the test was successful. This project will be launched very soon, April this year, next month. Okay, this concludes my presentation because now just a few words about ongoing and future work. Right now we are moving Caliper in production. As I mentioned, the project phase is recently over. NOCS, the names of countries and territories, that is a service of a terminological service of FAO, has adopted Caliper for its daily regular maintenance, and the website of Caliper is in this move to migration under an FAO domain. Future, we want to include output for compatible with SDMX, and we are interested in collaboration and peer review under many points of view. And especially for the modeling, we're interested in exchanging comments and views about the modeling decisions and the modeling approach taken. Of course, there are other points in our mind and our ideas, but these are the main ones. Finally, just a recap of pointers, the two addresses for the website, and just two of the tools. One for the editing of Workbench, and the other one is Cosmos, is for the visualization browsing of classifications. This really concludes my presentation. I'm very happy to take questions.
Thank you, Katrina, and thank you, Carola, for an excellent presentation and an overview of the work of FAO on Caliper. As you said, I'll open it for the floor if there are any questions. There is conversation taking place on the chat on the more sort of insights that you talked about to further support your presentation. I think this really sets it more clearly out in the way we can start using the semantic enabled sort of classifications in different types of applications as we see them, basically allowing for the user to use semantic web techniques to actually search and make accessible information, but also to allow machines learning and machine enabled sort of searches to take place much more sort of systematically. And you have set it out very nicely. I do not see any immediate questions, and looking at the time, I suggest that we move on to the next segment, and the next segment is a presentation, a joint presentation by 4 of my colleagues from the United Nations. Most of them are information systems officers as well as data engineers. But they will look at a particular applications that they have worked on, which is the SDG ontology, in making the SDG indicator or systems much more sort of searchable, not only in terms of data, but also in terms of text, in the way you know, the SDG indicators and their descriptions are used in papers and articles, also in the UN library. So with that, I would like to turn to Luis Gonzalez Morales, a colleague from ourselves at the Statistics Division, who will be followed by Amit Josh. He's also from Yoshi, who is from DESA, who will also contribute following Louis' presentation on his work on the SDG ontology, followed by Aaron Helton. He is the information system officer from the UN Library and has worked on the metadata.un.org, which is a metadata open metadata structure that is used for the UN vocabulary. So he will and explain that in more detail, followed by Sean Lovell, who is a data engineer from Statistics Division that actually worked a lot in combining this work in microservices to enable the SDG ontology. With that, Luis, the floor is yours.
Thank you, Ivo, and thank you, everybody. I hope you can hear me. If not, let me know. This is a presentation, as Ivo mentioned, of a joint project that was run collaboratively among many offices involved in the UN. It's a truly collaboration effort that illustrates the use of linked data, semantic web technologies in the domain of the SDGs, and I hope this could provide some inspiration, some ideas for reflection and improvement, also to expand to other domains, as in the domain of economic statistics. So let me see. I will fly through the presentation, so to make sure that we have time to have at least some discussion at the end. So we started with the challenge presented by the 2030 agenda of making timely, high quality disaggregated data available and accessible so that decision makers can use it to implement and monitor the progress towards the SDGs. So the challenge was not only to, or is not only to fill data gaps, but also to integrate different sources of data and other types of information, not only statistical data, so that they are available in a meaningful way to decision makers. Now, to address this challenge, we come across the semantic web. The semantic web technologies provide a means to enhance information seeking, to target the information more precisely, and to integrate those different sources of information through metadata. And the goal of these semantic web technologies is to use those metadata about very different resources which are distributed across the web, available so that third-party applications and users can find them, can access them, and then can make inferences, reason on them, and operate on them. So by bringing the information to the semantic web, we achieve those goals, but we need to have this information available with metadata that is standardizable and machine readable. So let me start by showing you the end result, and then we will go a bit with the inner workings of how did we get to where we are at this moment. So the project is called Linked SDGs. It was developed by the Statistics Division and the Division for Sustainable Development Goals of DESA, with resources from a EU grant. And also, as I said, with the collaboration of many different offices, from the Hamashul Library, and also collaboration with colleagues from academia that chipped in with their expertise. So this tool allows us to collect SDG-related documents using open data techniques with statistical data. It provides a foundation for that exchange and to make some information resources more visible, interoperable, and usable. So to give you an idea of how it works, the key features, what it aims to do and what it achieves in this application is, provided a document, it extracts concepts related to the SDGs. It extracts concepts related to geographic areas that are mentioned in those documents, and then links them through with some sort of visualizations as well to the statistical data, making the statistical data that is relevant to a particular document available. And it supports multilingualism and is developer friendly. We will talk about those details later on. So in a nutshell, one provides a document. It can be a PDF, a Word document, a web page, and extracts the concepts. So there is some mechanism to extract the key concepts out of this text document. And then these concepts are linked to the SDGs, targets, indicators, and to the statistical data series. To show it a little bit in action, let me go to. I hope you can see my web browser now, which is the web page of the application. I just wanted to show you an example. So I picked one document which is available on the web in PDF format in Spanish. It's it's from UN Women, and it's about it's the annual report 2019 to 2020. So let's see here. If we put the URL in the application and click analyze, what we get in a few seconds is concepts extracted from this document. So obviously, it's not surprised that the most frequent concept is about women, gender equality. There is something about violence, etc. So what you can see here is that concepts in Spanish are tagged and then identified to the English concept. So these are the main concepts included in this document. And these are also the geographic areas that are mentioned in the document, which are most relevant in this document. So with that, by having tagged the concepts, it is now possible to link to the SDGs. And how does that happen? So, for instance, obviously, the most relevant goal that can be linked to this document is goal 5 about gender equality. And the most relevant targets are also indicated here, for instance, 5.3. So how is this? So this is related to the concepts extracted from the document, woman, gender equality, and so on. We can go up to the indicator level, and then by having arrived at the indicator level, we can also link with the relevant data series for that indicator ordered in the order of importance of the regional areas that were extracted. So this is the application, and I will not delve more into it. It's just to show you the power of linked data technologies, in the sense that it is possible to link different information resources that reside in completely different servers, domains, through this infrastructure. So how do we bring the SDGs to the semantic web? The overall picture is this. We start with a body of knowledge that is the UN institutional knowledge. It's explicit, implicit knowledge that is generated by the UN system over the years. This knowledge has been painstakingly, carefully systematized, formalized by the UN library over decades in what is the UN bibliographic information system. This is an artifact that embodies a lot of the knowledge from the UN over decades. And it's maintained by the library, and my colleague Aaron will explain a bit about that. So this knowledge, which is embodied in this bibliographic information system, is used traditionally to catalog and to identify documents. And it is linked to other vocabularies like Eurovoc. So the UN BIS being available in all the official languages of the UN, and then linked to Eurovoc, which has many more languages, opens up really the possibility of multilingualism, of moving from one language to the other automatically. So now comes to the picture the 2030 agenda, the SDG indicator framework, that in itself is part of the institutional knowledge being developed by the UN system. We have the voluntary national reviews, which are documents produced in order to monitor this agenda produced by member states. And this is where we found the opportunity to develop what we call the SDG taxonomy, which formalizes in semantic web sort of technology the knowledge embedded in the 2030 agenda, in the indicator framework, linking it to the bibliographic information system, so that then we can also start analyzing different documents, including the VNRs, and linking them to statistical data. Because the statistical data can also be linked to that taxonomy. And so that allows to start linking, as I showed in the application, a textual document with the relevant statistical data. And now comes also many further applications as the ones that are being discussed in the economic statistics domain. So how to make all this methodological guidance that is produced by the UN system and other partner organizations also available in the semantic web. And by doing so, we just see statistical classifications and so on. All of that becomes part of this semantic web, this web of knowledge. So that's the vision that we have. But to do that, we need to create semantic content, and this semantic content requires a critical mass for the wide adoption of these technologies. And so the question, the challenge is, how do we create these ontologies, these artifacts? Ontologies, as was explained before, provide the means to formalize and express a common understanding of a particular domain of knowledge in machine processable form. And they provide both the vocabularies and the relationships between concepts, so that they allow us to interlink and meaningfully different types of resources. So we need to be able to create ontologies in the domains that we are working on, and use the ontologies that are already existing, and also based on those, we need to be able to annotate with semantic metadata the documents, the resources that we want to interlink. So this requires domain experts, knowledge engineers, and developers of tools. So it's a complex process. And in the case of our project, it was not an exception. We also had to go through the process of an ontology creation that started with domain analysis, looking at the knowledge sources, documents, and so on. And Amit will talk about that. Producing some first draft, some first conceptualization of the domain. So what are the goals? What are the targets? What are indicators? What are the data series? How do they link into each other? And formalizing this knowledge into a prototype ontology that then has to be refined, validated in various iterations until we have a working version ready to be used. So with this, sorry, I forgot. Also, once we have the ontology, now we need to work with it. And the other part, as I mentioned, is the annotation of documents with semantic metadata. Some of it can be done manually. Some of it can be done with some natural language processing techniques, which is what I showed you in the application. There are other more sophisticated methods being used also in other domains, using machine learning algorithms. All of these are valid ways to create semantic annotations, and we need to do that also in one way or another when we are publishing information resources that we want to be available on the semantic web. Thank you, and I hand over to my colleague Amit, who will explain a little bit more on the details. I will be passing the slides, so Amit, please let me know when you want to move.
Thank you, Luis. Hello, everyone. You can hear me, right?
Yes, we
Hi.
can hear you.
Hi, this is Amit Joshi, and I work for the United Nations in the Department of Economic and Social Affairs. For the next few minutes, I will share with you the current state of the SDG knowledge organization system that we have built, and also show you the simple steps on how we did that. Next slide. The knowledge organization system consists of an ontology that models the core elements of the global SDG indicator framework, which includes 17 goals, 169 targets, and 231 unique indicators, as well as more than 400 related statistical data series. The first step in bringing SDG data to semantic wave includes the formalization and establishment of unique identifiers for the components of the SDG and their indicator framework. We built ontology that includes mapping of each goal, target, and indicator and data series to relevant terms and subjects in vocabularies such as UNBIS and Eurofolk. This enables making SDG-related data and information assets more accessible, interoperable, and reusable. This also allows users to organically discover relevant and information and authoritative information related to SDG. I just saw earlier in the demo, our knowledge organization system enabled the development of applications that integrates SDG authoritative data, concepts, and definition from large number of online sources. Next, we look at how we build a simple taxonomy. Obviously, we start with a goal, and as we know, each goal has one or more targets. So we establish a connection between goals and targets using a property called hasTarget. We follow the same and establish connections between targets and indicators with hasIndicator property, as well as indicators and series with hasSeries properties. What we also did is we extended all these goals, targets, indicators, and series by establishing a connection with various vocabularies and concepts using a property called DCT subject, which is part of the data catalog vocabulary. Next, we saw more extended version of this taxonomy. As I explained earlier, we connected each resources to relevant terms and subjects in the UNBIS and Eurofolk vocabularies. What we further did is we extended the goals and target with additional properties, including the inverse relationship, in this case, like is target of, as well as taking advantage of widely known SCOS vocabularies. SCOS is Simple Knowledge Organization System, which was also used in the earlier presentation by our colleagues. We did the same for targets, indicators, and series. Next, we'll look at how we go from a PDF document to a more structured data. On September 2015, all members of UN adopted this 2030 agenda centered around the 17 goals and 169 targets. As a follow-up and review of the implementation of 2030 agenda, the UN also adopted 2017 SDG indicator framework. Next slide. This is page 14 of the 2030 agenda, listing all the goals. What we wanted to do was to reflect whatever is there in these PDF documents, the resolution and the global indicator framework, and then mimic for the semantic consumption of this data. I mean, in the form of semantic data. So next, I want to show like how we build triples and link data using this document. Let's look at this SDG1, which says end poverty in all of its form everywhere. And here we tag the proper poverty. And next, you can see we established a connection from this text to UNBIS vocabulary with that particular ID in the UNBIS thesaurus, which defines poverty. And we manually establish this connection. And next, we also established there's another term called poverty in the Eurofolk. So we established another connection using DCT subject. And we also found one more, that there's another term called poverty mitigation, which we think end poverty is what it means, right? And that's how we establish. Furthermore, we also look at other vocabularies and other thesaurus. In this case, we say that it matches exactly to what it's mentioned in the Wikidata. and another one we have in the SDG-IO ontology. So as you can see, we started from one simple text in the PDF document, and we started establishing relationship using the existing UNBIS and Euro vocabularies, and at the same time looking into other thesaurus or ontologies that already exist. In our case, is Wikidata and SDG-IO ontology. Next. Thus, in the multilingualism side, as the SDGs are United Nations issues, it's an important part that we cover as many languages as possible. At the moment, all our contents are primarily in English. Roughly around 50% are in French and Spanish. This is primarily for goals, targets, and indicators. We still have a lot to do in terms of multilingualism for this series, but other languages are also planned for being added to the list of lexicalization. Furthermore, because we map to Eurofolk and UNBIS, it enriches the multilingual capability of our system, because both of these contain large number of concepts across many domains, and as well as they are in multilingual themselves. In particular, if you look at the UNBIS thesaurus, it contains more than 7,000 concepts across 18 domains and 143 microthesauri, with lexicalization in the 6 official languages of the UN, providing one of the most complete multilingual resources within the United Nations system. Next, we show how we can exploit a simple chaos SCOS pref level property to create additional triples in various languages. In left, we see target 1.1, and in right, we see how it can be depicted using pref level for different languages. Can you click next? Yeah, as you can see that we put the same goal target 1.1 in language English, Spanish, and French. That's how we achieve multilingualism. That's a simple overview of our SDG chaos, capturing taxonomy and linking it to UNBIS and Eurofolk, and how we were able to achieve multilingualism. I will let my colleague Aaron to speak more about metadata.un.org initiative, where the SDG ontology is also hosted. Thank you.
Hello, everyone, and my name is Aaron. I work in the UN Library here in New York, and the UN Library is providing the metadata.un.org platform. Yeah, there we go. So the metadata.un.org website provides web resolvable URIs for the SDG taxonomy and the UNBIS thesaurus, both of which have been described previously. Next, yeah. But what's sort of implicit about moving to semantic web technologies is the use of web resolvable URIs. To unpack that, what you need is to actually have something that can be brought up in a web browser, right? You have to have a URI that can be resolved to something. It doesn't always have to be human readable, but it should be at least machine readable. It's also nice to be able to showcase what's at the URI for a human readable version. Now, we started this this sort of move to a linked data and semantic web approach in the library back in 2013, when the entirety of the UNBIS thesaurus was contained in a Lotus Notes database, and a very antiquated and very unlinked Lotus Notes based website. So in 2013, we came up with a project to map the concepts between the UNBIS thesaurus and the Eurovoke. So we worked with the EU Publications Office to develop a project and a roadmap for this. Before we could even start, we had to get the data out of our Lotus Notes database and transform it into a linked data structure. We settled on SCOS for what I hope are fairly obvious reasons. I mean, the thesaurus is a way of organizing knowledge and terms and things like that. What we also found in the process is that we had to extend this a little bit using, and we found that Eurovoc actually had already solved some of the problems that we were approaching ourselves. So for instance, Amit had mentioned that there are 18 domains and 143 microthesauri. Those concepts come from Eurovoc. They're specifically defined in Eurovoc's ontology. So we liked those enough that we adopted them for ourselves, which is one of the benefits, by the way, of this kind of reuse and interoperability, is that if somebody has implemented a thing that that works well enough for your purposes, instead of reinventing, you can just adopt what they've done. In cases of data, the specific concepts and terms, that may not always be the case, but especially in terms of structure, I think the usual approach is to find something that fits first and reuse that rather than developing your own. But always feel free to add your own nuance, and this is the approach taken with the SDG taxonomy. So the result of a months-long project, I think it took the better part of a year. Now we have an alignment between Eurovoc and Unbus Thesaurus, some of the results of which you've seen elsewhere in these presentations. You can, this is something that is, it's maintained in that we have, we've been in recent contact with the EU Publications Office to provide them with our updated URLs. When we started the project, the only URLs we had were our old libthesaurus.un.org URLs. We didn't even have a concept of metadata.un.org at the time. So that took a while to develop. And once we did, we provided them with the updated URIs, which they published the alignment result on their website. For various reasons, we're not making those public on our website, but they are in the data that you can download from metadata.un.org. Can you go to the next slide? Okay. Okay, well, we had a few reasons to develop something like metadata.un.org. One is that, as I was just describing, that all of our URIs pointed to the old Lotus Notes website, and this website didn't have any concept of linking between terms. So even though it exposed relationships between the terms, you'd have to go and search for them or browse through the hierarchy until you found them. And so we thought we could do a little better than that by making use of linked data. Additionally, there's been growing pressure to retire Lotus Notes applications throughout the UN because we're phasing out Lotus Notes. So we needed a new website. Took us a few years to kind of build through the ideas of how to host a linked data website that modern enough and made the URIs easily resolvable. So we had, I would say, well, I think I made maybe 4 or 5 projects myself trying to do this, and we finally managed to get enough momentum going so that in 2019, with the collaboration with DESA, we were able to finally deploy a finished version of metadata.un.org to coincide with the SDG taxonomy. But none of this would have been possible, in fact, without the work of my library colleagues throughout the decades of the Umbus thesaurus's overall life. So while there were technical challenges in terms of developing and maintaining a website, and that's absolutely a crucial and necessary step. That's not where I see the bulk of the work having been undertaken. So that old Lotus Notes data, our library taxonomists had based the structure of that on an ISO standard, 25964, right, which is a standard for thesauri. Right, the transformation of that data followed the W3C's Strauss recommendation, of course, with some modifications based on the Eurovote standards. And we have, of course, in the library our taxonomists who specialize in maintaining the data, including its structure. And as we were developing the SDG taxonomy and making this available online, those same taxonomists consulted on the mappings between the Umbus thesaurus and the SDG taxonomy, so that we could have at least some level of confidence that a particular SDG goal, target, or indicator was actually related to the subject that had been chosen for it. So I think overall, what I'm trying to say here is that, yeah, there's definitely a technical component to this, but if you're going to do this, I would encourage you to look at the existing international standards, consult professionals, because there are professionals who do this, and to remember that that you're not doing this alone, because there's a community of people who are doing this work. And I think now it's time for Sean to tell us about some more technical details.
Yeah. Hi, everyone. I'm Sean Lovell. I work in UNSD with Luis and everyone else you see here, really. So I guess at this point, we're sort of jumping from, the intellectual infrastructure that underpins the application that you saw. I mean, really, if we had to define the heart of it, it's these ontologies that made everything possible. But to get from these concepts as they exist in the URIs into a web application took a little effort. And I have to say, the web application was built by an incredible team, and some of the people that built the microservices aren't here on the call. So I'm presenting on the end of a process that began with another crew. So there is a little bit of a leap here in the story about how we went from these concepts to what you're going to see next. But I'll try to fill in the gaps as we go. So the linked SDGs application that you see is actually a distributed system with a React front-end application and 5 API-based microservices that are written in Python. So, and it's backed by an Apache Jenna Fuseki triple store database. So, just to illustrate to you the simplicity of each of these microservices, I mean, the code is open source and you can take a look. It's actually, each one is just a Python, a single file Python application. Sorry, one sec, I hear a loud noise. So the brilliance, I think, of this application is really in how it adds a computational layer on top of the very powerful ontologies that were created, and exposes the possibility of linking these concepts. So the challenge that we had was essentially, we have these different microservices, we have the front end, and the challenge was to sort of consolidate it into one code base conceptually, so that the application could be easily deployed. So we have these different code repositories, and this made sense from a development perspective because it's very easy to develop on each of these microservices. You can sort of tinker with them. Each part is not complex enough where you'd feel overwhelmed. You can break it down into these small chunks. From a deployment perspective, a lot of us on the team, at least we had limited experience working with microservices on our site. So this was something that was relatively new to us, and so we had to take a different approach than we would have taken had we been using our traditional UN, statistics approaches. So we had issues, configuration, dependencies, routing. All this would need to be manually configured if we deployed it. If the overall system went down, suppose we had patched all this together, configure these microservices to be self-aware and to have the database configured and install all the dependencies. If the system goes down or needs to be moved, it would be a monumental effort, at least because this is an experimental sort of free time, if you will, application project. It wasn't really part of our core work. So none of us really wanted to be hit with a bill in terms of spending 2 weeks time to bring the thing up if it went down. So we had to have something that was really easily manageable. So it also lacked basic monitoring, observability, and all this stuff. This was all part of the consideration, if you will, in terms of how we took the next approach. So next slide, please. I think so we sort of unsurprisingly, we decided to go with containers. We thought this would be a better approach, and it was. So we sort of had a realization that we had to containerize it, and that meant we'd need to have some sort of a smart container orchestrator. And we decided to go with Kubernetes because we did have experience on our side, on the UN Global Platform team, sort of implementing Kubernetes resource descriptors. So that was something that I felt comfortable with. So for those of you who don't know, a container is just a standardized unit of software that packages code and dependencies together. So that you can have different versions of dependencies running on the same operating system. And this is powerful because it's really conceptually what you think a container is. It allows you to safely keep different versions of your bin and your libraries, if you think in Linux, keep them conceptually separate so that you can use the same kernel without polluting everything or needing different virtual machines. So it's a very lightweight way of packaging software. So it's really about this, building software very close to its operating system dependencies, so they're tightly coupled. And Kubernetes, of course, is a platform for managing containers because a container itself is one thing, but if they communicate, you have to have DNS, you have to have networking, you have security considerations. So all of this is handled by the Kubernetes layer. So together, if you really break it apart, the application is very simple microservices built into containers and managed through Kubernetes. And I think that conceptually, if you wanted to do something similar, I think that's an approach that makes sense, and that's worked really well in terms of keeping each element relatively simple. So I don't want to go too much into this, but the benefits were, if one of these microservices went down, Kubernetes would start it back up again. None of us would need to wake up at 3 in the morning and try to figure out how to restart it. It handles configuration, so all of your what's traditionally infrastructure now becomes part of the code base, which is nice because all these things that you'd handle with your ops team now become part of the software itself. So you can run it on your laptop you can make sure it works. You can make sure all the DNS is working, all the containers can talk to the database and the security model so that it's not, all of this you can do locally, which is nice because you don't have to have a massive cloud spend built to try to figure out how to get this up and running. And then once it runs locally, there are just a few minor configuration changes and you can pop it up to Google Cloud or Amazon or Linode or wherever you like. So yeah, and then of course, yeah, you can patch it easily because all the software is in the container itself. So patching the software becomes just a simple process of rebuilding the application, so long as it exposes the same contract to the other microservices. So just the plan of attack. If you go over this, the approach we took was to containerize each microservice one by one, starting from the bottom and working our way up. So we started with trying to get the Apache Jenna database containerized, which was probably the most complex part of it. So when I say we, I mean there was really on each call I think everyone who's presenting was on these calls, and we're just trying to code, all three of us together, trying to get this working. Plus a few people who aren't here. So the approach, if you think of this microservice, it's a simple Python application, for instance. You want to make sure. So one of those services is a text service. So this service has one job, and that's to take a PDF file or an HTML link and turn it into a standardized text output. So this is Apache Jenna. So Apache Jenna is open source. It's very easy to implement, but it has some dependencies, and these dependencies need to be configured in the container. So that's how Docker, that's how we went about it. So we used Docker to define these. We also moved configuration out of the application and into the environment, which made it easy to pass environment variables from the Kubernetes orchestrator into each container at runtime. So we didn't have to reconfigure things through build processes. So we could basically take these containers and move them around to different environments, pass in, if the database URL or the front end URL changes, we could pass it in at runtime, and it would just absorb that, and we wouldn't need to rebuild the software, which made life very easy. And then we just exposed once we published these container files to a Docker registry, which we were hosting on the global platform, but it's also public. So that's the first that we did that for each microservice until we felt that we had each service working on its own. And then what we did is we decided to experiment with some basic sort of container orchestration. So we started with Docker Compose because it's very simple and it runs locally. So we ran everything using Docker Compose, and then we used the CLI tool just to migrate these into Kubernetes, which was which allowed us to build these auto-generated template files, and then we modified the auto-generated files to customize them and make them what was deployed. And finally, long story short, we deployed this to the global platform using these template files. So that's the plan of attack. Next one. So what did we learn from this development journey? So, I mean, this is not a closing statement, but just thinking about the breadth of the contributions that I saw when I was watching this presentation, hearing from my colleagues are saying, and what the different roles we've had. I want to start with point number 2 and say multidisciplinary teams were essential. I mean, each of us brought to the table very specific knowledge and experience. That was a very small team. And each of us was able to contribute in a way that enabled part of this to work. It really was a team effort. And my part was just one small part at the end. So I think it's really impressive how all this came together. So we needed to engage ontology experts, data scientists, alongside data engineers and ops people to ensure understand the code base and make it container ready. The other thing, which is more, talking about this last point, is that, I think that often what we don't have a good term for it internally yet, but we call it, really it's DevOps or data engineering, but this last process, is so often an afterthought in our work, or we contract it out, or we don't really see it as important to have these skills in-house. So dealing with distributed systems and dealing with software. So I think this is something that is kind of implicit when you're looking at digitally enabled economic statistics. digital enabled means software. So you need to be able to build software to consume these things, to manage them. If you want to do interesting things, you have to be building software. So the better you build software, the better your experience will be with managing these things. So that's just my belief. I don't mean to impose. And the final point was, code literacy was essential. I mean, all of us on this project, from the project manager, who I guess was Luis, and to the statisticians and the data scientists, everyone who was involved was a coder. That doesn't mean we all had the exact same knowledge, that we had cookie cutter identical skills. It was more of, a common language that we all had. So that enabled us to really solve problems in a very fast way without having to stop and sort of engage in some, Herculean mental task to translate this into, non-technical language so that someone else felt comfortable being part of the team. And I know that sounds somewhat arrogant, but it allowed us to do things quickly and efficiently. And this was essential. We couldn't have done it if that hadn't been the case. So nobody used the word IT. None of us were saying, oh, we need to get IT involved. No, there was none of that. It was, we're all coders. We all had a very specific understanding of our role, and we all contributed. So that's my part. So I know that there's a big gap in here because we sort of jumped from the concepts to the DevOps. And I mean, ideally, we'd like to show the application components, the front end application, the different microservices. But I do want to say it is open source. And if you're interested, just go through the project structure on the link and take a look at there's different service names. They're pretty obvious. There's text, there's graph, and then there's concepts. And you can kind of see in Python how everything's working together. So it's pretty straightforward. That's it from me. Thank you.
Thank you very much, Sean, for explaining that aspect of data engineering. If you have all these microservices, bringing that together in an integrated manner for operational purposes. So thank you for that. For some, maybe very technical, but I think it's an important aspect that has to be considered, as you have indicated. I'm conscious about the time. We're 10 minutes over the hour, and we would close at 6. So I see there are questions, particularly from Andrew Hancock, for instance, Sean, which I think we can take offline, take that forward. There was the question, was there any use of SOAP or REST protocols for data interchange processes? I think we can pick that up later in an email exchange. What I think is important to indicate in this context, and sorry I put on my camera now, is that I would thank all presenters from the different organizations that presented, our colleagues from New Zealand and from Canada, our colleagues from FAO, and our UN colleagues for making a presentation across a complex topic that we all engage in. I should mention in this context that there is a project under the update process of the system of national accounts and balance of payments to create digitally enabled standards and classifications. So that's the context in which we actually organize this alongside the Statistical Commission. The good thing is that this is a new area for international standards. As you've seen, there's been a lot of work being done on classifications, but we think that digitally enabled standards will help us enormously in understanding and making accessible our international standards. But in the process of update of these standards, like the system of national accounts and balance of payments by 2025 has been decided by the Commission, we think that this technology would really help us also in the whole update process, understanding the consistency between standards and classifications more broadly, as we then increasingly start moving this also in statistical production processes if you want to develop balance of payments of national accounts. So because you can now enable all these concepts in a way that you bring them into your questionnaires, you can bring them, search them in administrative data in a more systematic way. So what we are enabling here is an environment of a metadata management system around international standards that will transgress towards administrative data, but also more broader articles and papers, as been indicated by Louis, you pick up a document, you digitally enable it, and then you will be able to do quite a bit of analysis related to the SDGs, but also you can do it related to national account concept and economics that we want to enable. So it is a new environment that we have to work on. We do understand that this is a project that doesn't come overnight. We saw with Caliber and with the relationship to ARIA and its development, but also the SDG ontology, that it quite takes years rather than weeks to actually develop it. And as Sean has well articulated, it requires a multidisciplinary team, not only of statisticians and subject matter specialists, but also data scientists and engineers. And we also need ontologists, so those that understand thesauruses and vocabularies to actually build it up in a systematic way. The good part of this work is that, and that's what we will do, is that we will learn a lot from the practices that we have seen today and from others, to actually start working on digitally enable the system of national accounts and balance of payments and international classifications. But it needs a collective effort, what we call co-investment at the global level, in which we would like to invite you to participate in the different elements of the task team, which we will share also on our website. So if you would like to follow us in this journey, or may even be interested to join us in that journey, then please feel welcome. It is a collective effort, as Sean has indicated, and he has indicated very clearly the expertise that is required. And we look forward in taking this journey forward. I'll stop here. I think, again, the presenters for explaining it so clearly. The presentations will be made available on the webpage for this side event. I also would like to thank my colleagues at the back end, Benson, Sim, and Pio, for their excellent work in organizing this webinar and making sure that I maintain informed about what is happening on the site. So thank you very much all for making this tremendous effort, and I look forward to taking us on this journey, which will lead, and that is the outcome, a deliverable of digitally enabled standards of the system of national accounts and balance of payments and classifications by 2025. So we have a journey to go on, and I look forward working with all of you in making this happen. Thank you all for staying on, and I wish you a pleasant day wherever you are. Thank you very much. Bye-bye.
Thank you. Bye-bye.
Thank you.
Thank you all.
Thank you. Bye-bye.
Thank you.
Thank you.
Thank you.
Thank you, Ivo. Thank you, everyone.
Thank you.
Thank you.
Have a nice
Bye.
day.